When we talk about the laws of nature, things like gravity or thermodynamics,
Mm,
what exactly are we talking about?
right.
Are they just incredibly precise descriptions of how the universe behaves, or do they actually, dictate how it must behave?
That's the big question.
Welcome to the deep dive, where we take a stack of your sources and, well, we try to extract the most important nuggets of knowledge.
Hmm.
Today, we're plunging into a really fascinating intellectual conversation. It's captured in the excerpts from Laws of Nature, Description or Constraint.
Yeah, it's a great discussion.
It really is. This deep dive tackles a fundamental philosophical puzzle, right at the intersection of history, metaphysics, and physics. It features this lively discussion between two thinkers, Barry and Eddie, guided by Kurt.
A classic setup for exploring these kinds of ideas.
Exactly. So our mission for you today is to unpack this core debate. We'll explore whether the laws of nature are just summaries of what we observe, or if they truly act as, fundamental governing constraints on reality itself.
Description versus prescription, basically.
Precisely. We're here to give you the shortcuts to understanding why this isn't just some abstract philosophical argument, but something that profoundly shapes how we understand the very fabric of our universe.
It really does. It affects how scientists even think about their work.
Okay, so let's dive into this core debate running through our source material. On one side, we have what's called the unifying, or maybe better, the descriptive view. This is a position championed largely by Barry in the discussion.
Right, Barry's side.
So Barry's argument, essentially, is that laws of nature aren't what we might call primitive facts.
Meaning they're not just out there waiting to be found.
Exactly. Not fundamental independent truths. Instead, they're frameworks that humans develop to unify and summarize observations. They're simply patterns we identify.
So no cosmic enforcer needed.
That's his point. No enforcer telling nature what to do. Think of it like a weather report. It describes observed patterns, like it's going to rain tomorrow because of this low pressure system, right? But the report itself isn't causing the rain.
It's just a really good description, maybe even a prediction based on the pattern.
Exactly. Then, on the other side, we have the constraining or governing view, and this is represented by Eddie.
Yep.
His position is that laws don't just describe, they actually constrain and, well, govern what can happen.
So they actively shape things.
Yeah, that's the idea. This is arguably the dominant mindset in a lot of science, assuming laws actively explain why physical events follow specific patterns.
Right. Scientists often talk about laws making things happen a certain way.
He'd say this is more like traffic laws. They don't just describe how cars tend to move, they actually dictate the allowed movement.
And there are consequences if you break them, unlike the weather report.
Precisely.
And that's exactly where the profound philosophical chasm opens up, isn't it?
Yeah.
Those two analogies, the weather report versus traffic laws, they immediately highlight the core tension. It's not just semantics, like you said.
No, definitely not.
It forces us to ask, is reality fundamentally following some kind of rule book? Or are we just getting really, really good at describing its astonishing regularities?
It shifts how you even begin to approach scientific inquiry.
Absolutely.
It really does. So let's zoom out for a moment. Where did this entire idea of natural laws even come from in the first place?
Good question. Where does the source trace it back to?
Well, the source highlights René Descartes as sort of the father of the modern notion.
Descartes. Okay.
He saw natural laws as mathematical rules expressing how God moves matter. He believed God was essentially a master mathematician, so the universe must follow these elegant mathematical principles.
God the geometer sort of thing.
Kind of, yeah. And what's fascinating is how Isaac Newton, in many ways, came along and, well, fulfilled Descartes' vision, even if maybe unintentionally.
Right, with his laws of motion and gravity.
Exactly. Newton gave us this small set of incredibly precise laws like universal gravitation that just seemed to unify all of nature under these mathematical rules.
And that was a huge shift from earlier philosophical views, wasn't it?
Totally radical. Think of someone like Aristotle, for instance.
Right. Aristotle's physics was very different.
He believed natural order arose from the inherent powers or forms of objects themselves. A stone falls because its nature is to seek the earth.
Not because some external universal law is dictating it, more like an internal tendency.
Exactly. This fundamental difference really highlights how radical Descartes' and Newton's mathematical universal law approach truly was.
Yeah, it sets the stage for this whole debate.
And this is where it gets really interesting, I think. Barry challenges that notion of constraint with a crucial question. If laws govern, who or what enforces them?
The enforcement problem. Always tricky.
Right. In Descartes' worldview, as we just heard, the answer was clear: God.
God was the enforcer, the lawgiver.
But in modern science, the source points out the answer is, well, it's a profound question mark, isn't it? There's no clear enforcer that we can point to scientifically.
Yeah, exactly. Barry's point is, look, if there's no cosmic traffic cop that we can identify, why do we need to posit one? For him, unification alone is enough. If we can create a simple, elegant framework, a description that covers everything we observe, why add this extra metaphysical layer, this baggage of an unseen enforcer?
It's a very sort of Occam's razor approach. Keep it simple.
Kind of, yeah. It's a very pragmatic, minimalist view in that sense.
But Eddie, on the other hand, strongly defends that idea of constraint.
Right. He pushes back.
He argues that without it, unification might fail to really explain things. Why does nature consistently behave this way?
So description isn't enough for explanation in his view.
That seems to be the core of it. If it's just a pattern we observe, why isn't it ever broken? Why the incredible consistency?
Yeah, that's a fair question, too. The sheer regularity is staggering.
And he notes the scientists, in their day-to-day work, they tend to operate as if laws do have a real governing role. They expect experiments to yield predictable results precisely because of these underlying constraints.
They bet their careers on that predictability, really.
Absolutely.
What's fascinating here is this tension between what we observe, the patterns, and what we infer about what's causing or governing those patterns. Does the consistent behavior of nature actually require an underlying governing principle? Or is our desire for such a principle merely a reflection of our own human need for order and explanation? Are we projecting?
That's a deep question.
Yeah.
How much of our understanding of laws is just a human construct to make sense of it all?
Versus how much is an inherent property of the universe itself? It's not just an academic debate, like you said earlier. It shapes how we approach the very limits of scientific understanding. What counts as a good explanation?
That's a powerful point. Let's maybe delve deeper with a few more concepts they discuss. We've already talked about the traffic laws versus weather reports analogy.
Yeah, those are helpful anchors.
The source also introduces another concept to illustrate this: the least action principle in physics.
Ah, yes, a classic example.
Now, for those who might not be familiar, it's this really fascinating idea to just physical systems, like, say, a falling object or light moving through a medium. They don't just follow any old path.
Right, they seem to pick a very specific path.
Yeah, they seemingly choose the path that minimizes a certain quantity called action over time. But even this principle has these two interpretations, right?
Exactly. Does the universe truly minimize action? Like, is nature actively calculating and choosing the minimal path? That's the governing causal interpretation.
Or is it just a convenient mathematical summary of what happens? A neat trick that describes the path taken, but without implying any active choice or goal-seeking by nature itself.
It's just a descriptive shortcut that works incredibly well.
Precisely.
It's a brilliant example because it shows how even within a specific, powerful scientific principle, this core philosophical debate description versus governance plays out.
Yeah, it's not just abstract talk. It's right there in the physics.
And the conversation in our source also touches on unification and compressibility.
Right. Tell us a bit more about that.
Well, this is about whether the universe's laws can be represented simply. Can you boil down the rules of the universe into a relatively small set of principles?
Making them compressible, like a small computer file that contains a huge amount of information?
Exactly. Or does describing the universe require vast, perhaps infinite detail, making it incompressible?
And Barry notes that physics fundamentally operates under the assumption of unification, doesn't it?
Yeah.
Even if it's not strictly guaranteed.
Absolutely. It's almost an article of faith for many physicists. Think of Einstein's famous conviction that nature is unified, that deep down it's simple and elegant.
That belief drove his lifelong search for a theory of everything, even though, quantum mechanics and general relativity are still unreconciled today.
It's a powerful motivator, this hope that reality is ultimately compressible into elegant laws.
So it's almost a necessary working hypothesis for progress.
You could argue that. And if we zoom out again to the bigger picture, this idea of compressibility is really profound. Well, if the laws are truly descriptive, like Barry suggests, then maybe the universe just is its patterns. And our laws are simply the most efficient, compressed way we can write down those patterns.
Like, we're finding the ultimate algorithm to describe reality, but the algorithm is the reality in a sense?
Sort of, yeah.
Yeah.
But if they're prescriptive, if they govern, then the universe is actively following an instruction set. Our laws are then tapping into the code itself.
It really speaks to whether we are reading a beautiful, intricate book about what happens.
Or reading the actual program that is actively running the show. A very different feel.
That distinction really makes you
Yeah.
think. Okay, and this brings us to a final, crucial point from the source. Why are there no exceptions to the laws of nature?
The exceptionless character. That's a big one for Eddie's side often.
Right. So from Barry's descriptive view, if laws are simply unifying descriptions of patterns,
Then what would an exception even mean?
exactly, there's nothing really to violate. Nature simply follows these patterns consistently. It's like saying the sun rises every day.
Not the sun is forced by law to rise every day.
Right. There's no expectation of it not rising if it's just a description of a consistent pattern we observe. The pattern is the thing.
It's a bit like observing that under standard conditions, water consistently freezes at 0 degrees Celsius. You don't necessarily need a hidden force making it freeze at exactly 0 every single time.
It's just what water does.
Yeah, it's simply a description of water's behavior under those conditions. The very idea of an exception wouldn't quite apply in the same way. Maybe if you found something that looked like water but didn't freeze at 0, you wouldn't call it an exception, you'd just say it wasn't water. Or the conditions weren't standard.
Okay, that makes sense from the descriptive viewpoint, but Eddie's view counters that strongly, right?
Oh yeah. He argues that without some kind of governing principle, it's incredibly mysterious, maybe even miraculous, why there are no exceptions.
If it's just a pattern, why wouldn't the pattern occasionally deviate? Just randomly.
Exactly. Why this ironclad consistency across vast scales of time and space? For Eddie, or someone holding that view, that sheer regularity almost demands an underlying active constraint, something holding things in line.
Otherwise, it's just a colossal coincidence that the patterns hold everywhere, all the time.
That's the worry, yes. It feels less like an explanation and more like just saying, that's how it is. So this really pushes us to consider what explanation truly means in science, doesn't it?
It really does.
Does the sheer unwavering consistency of the universe demand a governor? Or does our human mind just interpret observed consistency as if there were a governor? Because that's how we tend to think about rules and order.
Are we imposing our concept of law onto nature?
Perhaps. It's a fundamental question that challenges our assumptions about how we understand and explain the cosmos. What satisfies us is a deep explanation.
Wow. Okay, so wrapping this up. What does this all mean for you, the listener? This deep dive into laws of nature, description, or constraint, it really reveals a deep fundamental divide in the philosophy of science.
Absolutely fundamental.
On one side, you have the view that laws are descriptive laws. Essentially, human summaries of observed regularities are best shot at making sense of the universe's pattern.
Our elegant summaries.
And on the other, you have prescriptive laws, these cosmic constraints that actively shape reality, dictating what can and cannot happen.
The cosmic rule book.
Yeah. And while Eddie sees this governing aspect as, well, essential for a true deep explanation,
Barry views it as unnecessary metaphysical baggage. Extra stuff we don't need.
for him, the unifying descriptive role is enough. It's the difference maybe between seeing the universe as this magnificent self-unfolding tapestry that we describe.
Versus seeing it as a complex machine running on pre-programmed instructions that we're trying to decipher.
Two very different pictures of reality.
Very different.
So here's something to think about, a final provocative thought. If the laws of nature are truly just our best descriptions and not inherent rules etched into reality, what does that imply about the future of scientific discovery?
Interesting question.
Does it mean we're always just refining our understanding of a universe that simply is, that just behaves consistently in the ways we observe?
Just getting better and better descriptions of the patterns.
Or does it perhaps open the door to a more, I don't know, fluid reality, where patterns could theoretically shift or change in ways we can't currently imagine?
If they aren't hard-coded rules.
Right. What if, in our search for the ultimate truth, the universe is even stranger than we can conceive? Maybe operating without any hidden rulebook at all, but simply unfolding in these repeatable, yet ultimately undescribed or perhaps even ungoverned ways.
A universe that just is in all its patterned complexity without needing a why in the sense of a governing law.
Exactly. It's something profound to mull over as you observe the remarkably consistent world around you.